of saying, oh, okay, this situation matches that particular rule, and those are the actions that we have to apply. And then the actions are also very mechanical. It's just, okay, we carry these steps and go from this as the input, and that becomes the output. So that's what we're going to do. All right. So now that we kind of have a rough idea of what pre and post conditions are about, let's start with something simple, which is a constant assignment. With a constant assignment, okay, let me give you the examples here using this particular thing. So if I say, line 1, okay, so this is line 1 here, and what line 1 is going to do is x gets 0. Okay, that's the statement on line 1 is an assignment statement. The precondition of line 1 is, let's make it, okay, let's say before line 1, we know x equals to 5 and y equals to 10. Okay. The post condition of line 1 is going to be what? Can we keep this part here? Nope, we cannot keep it. X equals to 0, exactly. But we cannot keep the other one because x is changed already. What about y? Can we keep that? Yep, absolutely. Okay. So every time you have what we call a constant assignment, you basically kind of have to forget what we knew about the variable, unless it is something that is very specific and it had for instance, it had the same value as before. But in general, what we can do is we can do something like this. We can say that the post condition of line 1 in this case is the result of forgetting something. But at the same time, after we forget something, we can also say that x equals to 0 because that's the effect of this assignment statement. When you specify what you're forgetting, you first have to say, what are we forgetting from? We're forgetting something from the precondition of line 1. And then you have to specify what exactly are we going to lose in this operation. We are going to forget everything that we knew about x. So that's how we specify the operation that we want to perform when we have a constant assignment statement. So the next step is to expand this. So we're saying forget. Instead of pre1, we'll actually plug in the actual condition of the precondition of line 1. And then after that, we look at this entire thing and say, okay, which parts do we have to forget? Which part can we toss away in this case? Or we have to toss away? Only the first part, right? Because this is the only part that contains any references to x. So we'll toss that away and we'll only have this part left. So that part is left after the forget operation. And on top of that, we still know that x equals to 0. X equals to 0 after the fact, because the assignment guarantees that x equals to 0 after the assignment. Is that okay? Okay. So does everybody understand what a forget operation does? Now sometimes there's nothing to forget. Okay, let me give you another example where there is nothing to forget. So let's say we are dealing with line 31 in this case. Line 31, y gets a value of 100. Okay. So let's say for whatever reason, we can guarantee that by the time we get to line 31, the following has to be true. Okay. We know that z has to be greater than k, and x has to be less than 300. Okay. That we know for sure. Every time we get to line 31, this condition is guaranteed. So in this case, what is the post condition of line 31? Well, guess what? We apply the same operation. So we say it is based on the forgetting of something in pre-31. We are forgetting everything that we knew about y. But after this line, we also know for sure that y equals to 100. So now we are going to carry out the entire operation. Copy and paste this here because that really is pre-31. All right. So at this point, what we are trying to do is to carry out this operation. This operation means The original one is z is greater than k and x is less than 300. And what we're trying to do is to forget all the components that has any mentioning of y. Is there anything that mentions y in the original expression? No. So that means there's nothing to forget. So we get to keep the entire thing. So after the forget operation in this case, we get to keep everything. And then on top of that, now we know y equals to 100. So do you think this forget operation is kind of mechanical? Yeah, it is. It's pretty mechanical. Okay, we got about 3 minutes left. So what I'll do is to start on the next one. Okay, so this is all about the constant assignment. It will get a little bit more complicated later, but for the time being, that's all we have to remember. And what we want to move on now is how to deal with assignment statements that has the same variable on the left-hand side and the right-hand side. Okay. In other words, we're trying to figure out, like say on line 45, we have k gets k times 2. Okay, that's the operation. So the precondition I want to say here of line 45, let's make it kind of general. K is less than z. Okay, that's all we know. What can we say about the post condition of line 45? Now the precondition doesn't say anything specific about k. We don't know the exact value of k, and we don't know the exact value of z.
K divided by 2 is greater or is less than z.
Yep, exactly. Wow. We can't actually say something about it because we can say k divided by 2 is less than z after line 45 executes. The reason why we can do this is because we know exactly what line 45 did to k. It doubled the value of k. And we also know how k related to z before the assignment. So that means if there's a way for me to quote unquote undo line 45, then I can go back to the same relationship that had to be true before that. And to undo multiply by 2, we divide it by 2. And that's why we can say k divided by 2 after line 45 will get back to the same value of k before line 45. And because that value was less than z, then this value, k divided by 2 after line 45, has to be less than z as well. So at this point, what we are doing is we are defining functions and inverse functions. Okay. So if I define a function f of x as x plus 1, okay. In this class, because I'm using a text editor, the inverse function, the -1 as a superscript is a little hard to do. So I'm just going to use f prime to denote the inverse function. The inverse function in this case is x minus 1. Okay, so the inverse function is really just how to undo something, how to reverse it. Are we doing okay so far with those concepts? Is everybody comfortable with the concept of a regular function? Kind of, sort of? Okay. So let's say, what is, now how do we know this works? Okay, how do we know that f of f is the, excuse me, f prime is the inverse of f? How do we know that? There's one test we can do, right? If I claim that's the inverse, that means if I apply the inverse to the function to a certain variable, I have to get x back. That's the definition of what an inverse function is supposed to do. It's supposed to undo what another function, or the inverse of it, is supposed to do. So in this case, I'll just go ahead and carry this out, and and then there'll be the end of this class. Okay, so in this case, f prime of f of x is f prime applied to f of x. But what is f of x? X plus 1. Okay, so that means this is just that, right? But what is f prime applied to something else? It's subtracting 1 from that something else. So that means this is really saying x plus 1, and then that whole thing minus 1. Okay, just by using the Is it called associative law? Yeah, because we can move the operation. So by using that law, we get x back because it becomes x plus 1 minus 1. And then we group these two together, and then the whole thing becomes just x. So this is proof that f prime in this case is in fact the inverse function of f. Now this relationship is kind of interesting because if f prime is the inverse of f, then f is also considered the inverse of f prime because they can undo each other. All right, so we're gonna stop here. You need to read a little bit ahead of me, to finish up all this discussion of self-referencing assignment statements, how to inverse all that stuff, and then on next Tuesday we'll start with this. I'll probably give you a homework assignment on loops, okay, and I'll send you an email when that assignment is up. All right, excellent, thank you.